Hi, now I would like to discuss a formula, the theorem for the force of interest. The theorem, the A of t, this is the accumulation function. So this is equal to the exponential of integral 0 to t delta r dr, delta sub r dr. So if we integrate the force of interest, then we put it on the exponential function. So that becomes the accumulation function. Yeah. So now that we want to prove this. Yeah, so proof. So proof is not difficult actually. The delta sub t is equal to a prime of t over a of t. So the key idea here is that this quantity is actually the derivative of a of t with respect to t. So this is actually the derivative of log of at. Right? So the formula of the derivative of log of at is a prime t over a of t. So actually using this, then you integrate both sides that you can get the theorem immediately. So the idea is just the force of interest. If you integrate it, that becomes the logarithm. So 0 to t, integral 0 to t dr, sorry, the delta r dr. So we integrate, then this becomes the integral of this right-hand side, but the differentiate, then integrate, then we go back to the original function. So we get the log of at. Here log is natural logarithm. Okay, log is natural logarithm. So at, and then you plug in t and 0. So actually this becomes a of 0 is 1. So log of 1 is 0. So this is the log of a of t. So note that the a0 is equal to 1. Okay. So now from this we can get, okay, so log of this. So we take the exponential on both sides. So a of t is equal to exponential of integral 0 to t delta r dr. So now this is the end of the proof. And one remark. So often we would like to calculate the a of something, a of t2 over a of t1. So how to calculate this quantity? And this is actually the exponential of 0 to t2 delta r dr by the theorem. And the denominator is exponential of 0 to t1 dr delta r dr. But this is the ratio, and this is exponential function. So you can see that in general, the exponential of a over exponential of b is exponential of a minus b. So you can see that this is exponential of integral that 0 to t2 minus 0 to t1. But that is integral of the t1 to t2 delta r dr. So it's convenient to use this because often that we want to calculate this ratio. We want to see how much the amount increased from time t1 to time t2.